Good afternoon. We're going to talk about rotational symmetry. So rotational symmetry is essentially if I can take an object and turn it some amount that's not a full turn, so less than a full turn, and it's going to look exactly the same as it did before I started turning that object, I'm going to have rotational symmetry. And look at this pinwheel. Looks like I have 4 triangles rotating about a central point, and this is a very good example of rotational symmetry. And I could take each one of these triangles, and if I rotated it a quarter turn, or 90 degrees, could be clockwise, could be counterclockwise, does not matter. But if I rotated each one of these triangles 90 degrees around that center point, around my point of rotation, or my center of rotation, I would end up at the next triangle. Or if I rotated this one 90 degrees about that center point, or that point of rotation, I'd get that triangle. If I rotate that one 90 degrees, I get the last triangle. And the way that we calculate the degrees of rotation is we are going to take a full turn. Well, what is a full turn? A full turn is 360 degrees. Think about, like a 360 degree windmill dunk, or a circle has 360 degrees in it. If you're doing a full turn, you're doing a full 360. I'm going to divide that by the number of shapes that I have that are congruent, that are rotating about that central point. So notice these triangles are all congruent. That's why I have rotational symmetry, so that they all match up with each other when I rotate this. I have 4 triangles. I'll divide 360 by the number of congruent shapes I have rotating around that central point, which would get me 90 degrees of rotational symmetry. And a key concept here is that any multiple of 90 would work. So 90 works. I have 180 degrees of rotational symmetry. I also have 270 degrees of rotational symmetry, or 360, or 450, or 540. Any multiple of 90 would work. So there I have rotational symmetry. A non-example would be number 11. This letter R, if I spin it, maybe 45 degrees, that's not going to work. That's not the same shape as that original shape. It's tilted. Or a 180 degree, or sorry, not 180, a 90 degree rotation, that's not the same shape. It does not look the same. 180 degrees, still not the same shape. 270 degrees, still not the same shape. So because I cannot spin this anything less than 360 degrees and get the same figure, this does not have rotational symmetry. So no rotational symmetry here. Number 10, let's see if I have rotational symmetry. If I spin this, so if this were on a piece of paper, and I could spin this, or if you're watching this on your phone, spin your phone, see if you can spin this less than a full turn and see the same shape. Well, this almost looks like an hourglass, and I know that if I flip an hourglass upside down, then I'm going to get the same shape. So if I were to flip this upside down, it looks like I would get the same shape. Or if I flip this 180 degrees, I would get the same shape. And let's test that. It looks like there's our center of rotation. I've got 2 congruent figures, one on top, one on bottom. So it's 360, a full turn, divided by those 2 shapes would get me my 180 degrees of rotational symmetry. It looks like this does have 180 degrees of rotational symmetry. let's look at a slightly different example. I want to go over to our three-sided figure here. It looks like there's our center point. It looks like I could spin this and get the same shape over and over and over again. It doesn't matter if I spin it clockwise or counterclockwise. This figure is congruent to this figure, and that's congruent to this figure, or at least they appear to be. So if I spin this, I'll get the same shape. I can rotate this leaf over here to that leaf. I can rotate that leaf over here to this leaf. And it looks like I have three, I'll call them leaves. So 3 leaves, 360 degrees is a full turn. Divided by the number of shapes we have, I would have 120 degrees of rotational symmetry. And then the 4-leaf clover, same idea. I've got these 4 leaves of my clover. I could spin this and get the same shape. So I could spin it, let's see, 360 degrees divided by the 4 leaves of the clover, 90 degrees of rotational symmetry. Check out the point symmetry and the line symmetry as well, and we will see you in class tomorrow.